Okay, so last assignment. Just have to watch this video, but you're going to be interacting a little bit with this one. There were 3 problems that I gave you the other day. So let's go ahead and go through those 3 problems. First problem was the stocks and mutual fund problem, where they told you that you have 50.3% of people own stocks and mutuals and all that fun stuff. First off, I want to go through the conditions. So we're going to start with the conditions because, again, this is the last thing. Okay. Now I'm going to read this to you, problem to you, and then I'm going to ask you your first of many, first interaction question. It has been found that 50.3% of U.S. households own stocks and mutual funds. A random sample of 300 heads of household indicated that 171 owned some type of stock. At what level of significance would you conclude that this was a significant difference? Okay, if we're looking at the conditions, my first question for you, SRS, is it given or is it assumed? Okay, for this problem, guys, it is definitely given. All right, independence. Do you think that the population is greater than 10n of whatever we're talking about? Well, again, we're talking about heads of household, so do we think that there are more than 3,000 households in the United States? And the answer to that is most definitely yes. And then check for normality. This is your second interactive question, guys. The question here is, how do I check for normality in this problem? Hopefully, you said n times p has to be greater than 5, and n times q has to be greater than 5. Well, that means that I have 300 times 0.503 and 300 times 0.497. And if you did those correctly, you should have gotten 150.965, something like that, and 149.3135. And this would have to be an 8 if that was the case. Okay, so there's your conditions. Hopefully you understand the conditions pretty easily by now. Okay, next question. What is HO? Okay, hopefully you wrote down that HO is P is equal to 0.503, and they want. This is a little bit of an interesting problem because they're asking at what level of alpha is it significant. So you would just want any change. Okay, so this is going to end up being a two-tailed test because it's just saying what changes, what level would that be a change. So since I'm not giving you an alpha in this problem, you have to come up with several different alphas. Now this should be rather easy for you. Okay, so I'm going to give you some alphas here, and I'm going to ask you what they should be. So again, this is a two-tailed test because we're just looking for a significant change. At what level would be significant? So I'm going to give you alpha equals 0.05. I'm going to give you alpha equals 0.02, and I'm going to give you alpha equals 0.01. And I want you to tell me which of these is the correct values for all 3 of those for this problem. Okay, as you can see, I have now written down the correct answers for those 3 alphas. And basically what you need to do is you need to find your z-score. Now, my next question for you is, what is the correct setup for the z-score? Choose one of these four answers. Okay, so now we have set this up properly. We have p hat, which is what was observed, the 171 out of 300, minus 0.503 divided by the square root of 0.503 times 0.497, all over 300. And we ended up with a z-score of 2.321. Now, guys, how do you know if this is significant or not? Well, you see, is this in the shaded area or not? Well, look at your numbers. What, plus or minus 1.96. Clearly, 2.321 is going to be significant there. So that this is, I'm going to put on here, this is a significant. Now this says 2.326 for 0.02. Well, 2.321 is not in the shaded region, so it's insignificant here. And hopefully you realize, well, if it's insignificant there, it's going to be insignificant there. So based upon the choices that you made, it is significant at 0.05, and it is not significant at 0.02. Okay, so that's problem number 1. Now let's go ahead to problem number 2. I'll read this one to you. Okay, this was a female physician problem. It says the percentage of physicians who are women is 27.9%. In a survey of physicians employed by a large university health system, 45 of 120 randomly selected physicians were women. Is there sufficient evidence at alpha equals 0.05 level of significance to conclude that the proportion of women physicians at the university health system exceeds 27.9%? Okay. So let's start out with our conditions again. In this case, SRS. We always look for that first. Is it random? Now, in this case, what does it say? In a survey of physicians employed by a large university health system, 45 of 120 randomly selected physicians. Well, it says randomly, so guess what? It's random. So that it means it is given. Okay, independence. Do you think, ladies and gentlemen, that there are more than 120 physicians in the world? Or no, not 120, 1,200 physicians in the world? Guys, there's probably more than 1,200 physicians in Frederick City. But anyway, so is the population greater than 10N? So I'm looking for a population greater than 1,200. So yes, I'm going to assume that there are more than 1,200 physicians. And now we've got normality, and again, because it's a proportion problem, we check for normality the exact same way we did in the last problem. All right, so our normality is going to be n times p greater than 5 and n times q, not g. I've never realized how hard it is to actually write with a stylus until I started doing this. All right, so n times p. Well, let's see, we've got 120 is n, and our p that's given to us is 27.9%, so I'll put 2.279. And then I've got 120 times 0.721 for n times q. And 120 times 0.279 is 33.5, approximately. And 120 times 0.721 is 86.5. Now both of those numbers are greater than 5, so we are in good shape. So our conditions are all go. Let's go ahead and get this problem done. Once again, I'm going to ask you, this time I'm going to ask you HO and HI, and which one is the claim? Okay, so we have HO is going to be P is less than or equal to 0.279. HI is going to say P is greater than 0.279, and that's going to be my claim. Remember what the question was. It says, is there sufficient evidence at the 0.05 level of significance to conclude that the proportion of women physicians at the university health system exceeds 27.9%? Exceeds means greater than. That has to be HI because HO always has the equal sign in it. So you've got to make sure that you have that straight if you go any further in statistics at all. All right, so what do we have? First thing we need to do is we need to find our critical value. Next question. How many tailed tests is this? And if it's one-tailed, which end is it? Okay, hopefully you realize that this is a one-tailed test. And it is right-tailed because we have the greater than symbol in HI. Remember, we always figure out our tails by what HI is. If HI was less than, it's left-tailed. If HI is not equal to, then it's two-tailed. If HI is greater than, then it's right-tailed. And HI will never be equal to. Why? Because HO has to be equal to. Okay. We said alpha was equal to 0.05. So since it's just one-tailed, what is the correct critical value here? Hopefully you got this one right. It should be 1.645. Now I know that you guys can't necessarily draw these little pictures when we're doing this online. One of the things that what you should do is you should identify your critical value by saying CV equals. And if it's plus or minus, then you would have plus or minus. Okay, next, find your z-score. Again, the setup's got to be right. You've got to put the observed of 45 out of 120 first, and then subtract what was given to you, that 0.279. And please make sure you're putting the right numbers in the denominator also. This is 0.279 times that 0.721 all over 120. So you get a z-score of 2.34. Okay. So, next question. Significant or not significant? Hopefully you revealed that it was significant. So, ladies and gentlemen, what do you write? Please choose one of these four solutions as the correct way to write the conclusion and your decision. Alright, so here we go. Because it is significant, we're going to reject the null. We don't think that this is happening by chance. We have enough evidence at alpha equals 0.05 to support that the proportion of female physicians is higher at that university. Again, key words. We do have enough evidence, so we have enough evidence because we rejected. And then we are supporting because, if you remember, our claim was HI. Support the high all the time. We know that you high schoolers like to do that. Support the high. And since you should be rejecting the ho as well. All right. One last problem. This one was the good old undergraduate enrollment problem. It has been found that 85.6% of all enrolled college and university students in the United States are undergrads. A random sample of 500 enrolled college students in a particular state revealed that 420 of them were at undergraduates. Is there sufficient evidence to conclude that the proportion differs from the national percentage? Use alpha equals 0.05. Okay, so let's talk about conditions first. First off, SRS. A random sample. Given or assume? Well, the problem says it's random, so what am I going to write? I'm going to write given. Independence. Okay, as far as independence goes, is the population greater than 10n? So do you think the population of undergrads, or do you think the population of college students in this particular state is probably greater than 5,000? I would say yes. And then normality. Again, because it's a proportion problem, we check it the special way. We have n times p has to be greater than 5. N times q has to be greater than 5. Okay, so we have 500 times what was given to us, 85.6%. There's a 0.856. And then we have 500 times 0.144. Okay. So we ended up with 428. That's greater than 5. And of course we end up with 72, and that's greater than 5. So we're in good shape as far as conditions goes. Okay. Once again, guys, I want to know what's the correct HO and HI here. Okay, so I have HO equal of P is equal to 0.856, and HI is P not equal to 0.856. And what is the claim? Is there sufficient evidence to conclude the proportion differs? So, HI. Now, again, since we have not equal to is there HI, that should tell us immediately that for our critical values, we're going to have two tails. And with it being two tail, what is the correct critical value here? The heavy panting that you hear in the background is my dog, who just came back from an Explorer. Not that he was supposed to be going on the Explorer, but he got loose. So anyway, back to the problem. I asked you what the correct critical value was. In this case, it's plus or minus 1.96. So you can write plus or minus 1.96, and hopefully that's what you put when you did this. Okay, so what comes after finding the critical values? Well, the next obvious answer is finding the z-score. At this point, hopefully you all are finding this correctly, but I'm going to try one more. I'm going to ask you one more time, which of these is the correct z-score? I'm hoping that you set it up and did the math correctly and ended up with a negative z-score because the observed of 420 out of 500 is less than 0.856. So you should have a negative z-score of negative 1.02. Now, comparing that to our critical values, though, negative 1.02, if I go back to my picture here, is going to be somewhere like right here. So, what is the correct, one last question, final question, what is the correct conclusion and summary for this problem? Again, you have to write the conclusion and you have to write the summary when you're doing these. Okay, so here you go. We are failing to reject the null. Okay, hopefully you got that part right. And since we failed to reject, we do not have enough evidence. And again, why do I have the word support here? I have the word support there because the claim was HI, and we support HI. That word is always support if the claim is HI. If the claim is HO, that word is always reject. Doesn't matter. I mean, if you follow it the right way, it will always be correct. If you put those words in there. Now, if you have the wrong claim, well, then obviously it's going to have the wrong word. But anyway, guys, it's been fun. There's a lot more that I would have loved to have gotten to. You basically got through about 3/4 of this class. But it is rather repetitive. There's some things that I would have really liked to get to with you later, but we didn't get to it, and we'll see what happens. Anyway, you all have been great. I really appreciate you. I appreciate this is by far the class that has actually participated the most. Of course, there was only 8 of you, and only 1 of you didn't. So, you can figure out that percentage. And I hope you all have a great summer, and I look forward to seeing some of you back in school sometime the next school year.